Welcome to the Speed and Velocity Higher exam questions and model answers for triple and trilogy students. Question 1. Figure 1 shows the distance time graph for a car travelling at 15 meters per second. Distance is on the y-axis in meters, and along the x-axis we have time in seconds. When the driver is tired, his reaction time increases, going from 0.5 meters per second to 0.82 meters per second. Determine the extra distance the car would travel before the driver starts braking. Now, from using the graph, I found that at 0.5 seconds the distance travelled was 7.5 meters, and at 0.82 the distance travelled was just below 12.5, so I said 12.4. In the mark scheme, it accepts anywhere between 12.2 and 12.4. So what is the extra distance the car has to travel before the driver starts braking? Well, it will be the difference between these 7.5 meters and 12.4 meters. So that gives us an answer of 4.98 meters. There is an alternative method that we can use, because we know the car is traveling at 15 meters per second, and we can see from the straight diagonal increase that it's a constant speed. We can use the equation speed equals distance over time, where distance is equal to speed times time, where d is distance, v is speed, and t is time. So the time we're going to use is the difference in time between the reaction time. So we take away 0.82 minus 0.5. So we got 15 meters per second for the speed, and we got 0.32 seconds for the time, which gives us an answer of 4.8 meters when we times the two together. So you get slightly different answers, but in the mark scheme, if you got an answer either using the graph or doing it the same way we just did then, anywhere between 4.7 and 4.9, then you get your marks. Pause the video, as I'm just going to scroll down and the answers will be removed. B. When the brakes are used, the temperature of the brakes increases. Explain why. Use the ideas about energy in your explanation. First mark, kinetic energy decreases due to friction, which is between the brakes. Second point, this causes the internal energy / the thermal energy of the brakes to increase. Part C, a lorry travels 84 meters with a constant acceleration of 2.0 meters per second to reach a velocity of 19 meters per second. Calculate the initial velocity of the lorry. Use the physics equation sheet. So using the physics equation sheet attached to the back of the questions, you'll see that equation number 1 is the one we need. Okay, I've underlined all the crucial information. Calculate means we need this equation, and it says the initial velocity. So now we need to rearrange this equation to make the initial velocity the subject of the equation. Looking to the right of the word equation, we can see all the symbols which represent initial velocity is u, final velocity is v, distance is represented by s, and acceleration is a. So rearranging that equation to have initial velocity as the subject, I'm going to use the symbols. So we see that the final velocity squared, take away 2 times the acceleration times distance, is equal to the initial velocity squared. So we've just rearranged that equation to make initial velocity the subject. But at the moment, we've still got initial velocity squared. So what we're going to have to do to both sides is actually square root it. So the square root, I forgot the squared from the v, of v squared take away 2 times acceleration times the distance. So remember, this v is still squared, and that equals the square root of u squared. The square root of u squared is just u. So now we've got the equation in the right format. All we need to do is plug in the numbers. Looking back at the question, I've written the symbols above each number. So the lorry travels so its distance is 84 meters, a constant acceleration of 2.0 meters per second squared. To reach, so its final velocity is 19 meters per second. Plugging this all into the equation, we get, which is u is then equal to 19 squared, take away 2 times 84, all square rooted, which comes out after putting in your calculator as 5 meters per second. Pause the screen here if you want to get the answers down. As when I move to the next questions, they'll disappear. Question 2. Speed and velocity are different quantities. Velocity is a vector quantity. The velocity of an object is its speed in a given direction. So a vector has both magnitude, so size, and direction. The graph shows a distance time graph for an athlete in a race. Determine the distance of the race and the time taken for the athlete to complete this race. Use the graph. Just going to scroll down. Oops, sorry. It's asked to determine, so we've got to use the graph, but it is also said use the graph. I've drawn 2 straight lines from where the race finishes, and that means I find the value for distance is equal to 42 meters. Time is 210 seconds. Oh, sorry, 10 meters. 210 meters. In fact, 210 minutes because it's time. Okay, get the answers down as they will disappear in a second as I move on to question 3 or 2C. So 2C, describe how you can use the graph to determine the velocity of the athlete 20 minutes after the start of the race. So I've just drawn a straight line which is a tangent to the curve up at 20 meters at 20 minutes. In fact, I've done it to 50 minutes, so I would redraw that line. 20 minutes needs to be to that point there, so that's 20 minutes. So I've drawn that line because that is what you need to do in order to find the velocity after that amount of time. First thing you do is draw a tangent. So a tangent is the line I've just drawn, which is a straight line which goes close to the curve on the graph. I've underlined I've circled 3 points and I've circled describe because that's what the question's been asked to do. So it's 3 marks, that's 1 mark. Second mark at 20 minutes. So I've drawn that tangent at 20 minutes. And the final point is to measure the gradient of the tangent to find the velocity. Why do we need to measure the gradient? Because remember, gradient equals the change in y divided by the change in x. Here the y is distance, so it would be the change in distance divided by the change in time, and that is equal to the velocity. So that's why we can take the gradient of the tangent. A car following the race accelerates at a constant rate in a straight line. Accelerates and concentrate on the line. The velocity of the car increases from 4.9 meters per second to 6.4 meters per second in 3 minutes. Calculate the acceleration of the car. Calculate means we're going to have to use an equation. We want an equation for acceleration. Another piece, it says give your answer to 3 significant figures. Okay, if we don't do that, we won't be able to access all the marks. So there's an equation for acceleration which says the change in velocity divided by the change in time is equal to acceleration. So here, our acceleration is going to be equal to the change in velocity, so we can work that out by taking away the starting velocity, the initial velocity, 4.9, from the final velocity, 6.4. Okay, so 6.4 take away 4.9 gives us the change in velocity. Now the change in time is 3 minutes. However, look at the units. The units are, the clue is meters per second squared. So we need to convert minutes into seconds. So 3 minutes equals 3 times 60, 60 because there's 60 seconds in 1 minute, so we get 180 seconds. So 180 seconds is the time that we use. Now, work out the difference. 1.5 divided by 180, which is equal to 0.008333 recurring. So it says give your answer to 3 significant figures. Final answer is 0.00833 for your final 4 marks. Now, sketch a velocity time graph to represent the acceleration of the car in part D. It says the car following the race accelerates at a constant rate. So that's the clue there. Constant rate means it's going to have to be a straight line on this graph. So choosing a point which we believe to be 4.9. Oops. We can draw our graph there and making sure it's a constant gradient, and making sure you've got the arrows pointing, and the velocity is on the y-axis and then the time is on the x-axis, and that's your 2 marks.